in the morning. Okay? And then we're going to have a 1.5 hour test. The test is going to be mostly based on, not mostly, it's going to be paper based. Okay? So you have questions, different type of questions, multiple choice questions, definition questions, write the program questions, the questions that will ask you to debug something. For example, why does this code doesn't work, and you have to explain it. Okay? The general ideas I will post online just to remind you what are the general ideas that we need to know. But the references that you use, chapter 9 and 10 of our book, the slides that are on SMART, the class notes that everybody is taking, and the project description. I will definitely put some questions about the Zelga project, Zelga, I'm sorry. Okay, and I also said when you're preparing, if certain concept is not clear, do use online references. Nowadays, this is sort of the best and the fastest way to get to things that you know. So let me actually go back to the interfaces here. I'm going to repeat it a little bit so we talk a little bit longer. And then I actually want to try to do it on your computers. So one more time, we finished, or sort of we introduced the interface. And as an idea, what was the interface? It was the abstract class taken to the extreme, right? Interface only has the signatures of the methods. And the main use for the interfaces is when you have certain classes that you want all of those classes to have a certain property. For example, the interface IComparable, that's actually a standard interface, it's already built in C#. And if you have a class, let's say I have a class square, and if we're using this colon sign to show that it's not extending, the usual term is it's implementing the interface. So it's going to be implementing IComparable. Which means that if you declare this class to be implementing this interface, that class is forced to have this method. It has to have this method. Now, why would I want to have classes to have the method compared to? And S2. If I want to compare the two methods, the two objects, I can do it S2. Okay? And as we discussed before, this has to be implemented in the class square. So I know for sure that this method exists. Not only this, the interface also comes with an agreement. And what is the agreement in this method? We already covered that.
Yeah.
So if it will be negative if what?
S1 is less.
If S1 is less than S2, it's going to be positive if S1 is greater than S2, and it's going to be 0 if S1 is equal to S2. However, right, so that's the general idea. However, we don't know what this less than or greater than sign means for the square, right? Automatically, it's not given to us. And that's why we actually have the method compare to. In this method compare to, we will actually implement what we mean by comparing two squares, right? And we're going to implement it in agreement with this interface. So let's write down the method compare to. So we'll have compare to method, and this is the method inside So let me for inside of the class square, right? So if I'm calling this method, then the object that is calling this method would be referred to as what? Inside of the method, what do we call the object itself? There you go, this, right? So this refers to the object that is calling the method right now. So in this case, if S1 is calling the method compare to S2, S1 is what? Inside of this method. S1 is this. And S2 is this guy, S, right? So with this in mind, let's write this method. It has to return an integer, right? This is already given to us as a signature. So it has to return an integer according to this agreement. How would we go? We will say something like this. If this dot what? How do we compare? We compare the squares by sides. Let's assume that we have an integer side already given to us, right? This is an instance field. So I have access to it. This dot side is less than s dot side. Then what do I do? Return. So the agreement is something negative. Usually it's -1, right? Then if, so we can put an else if, well, because it returns, if it didn't return, it means that we're going on, right? So if s dot side is less than this dot side, return
1.
1. Right. Else return 0. Okay? So something like this would implement the method compare to, and because our class is implementing this interface, it has to have this implementation. So I can actually use this just because I know that it implements this interface. Okay? In general, as I said, the interface IComparable is a built-in interface. And it's used every time C# assumes that it's going to be comparing two objects. Okay? And a lot of objects supposed to be implementing this if you're ever planning to compare them. As an example, let's consider the method sort. The method sort is the method of class array. What it does, it takes your array, and as you apply the sort, it will sort them in order. How do we determine the order? In order to determine the order, you need to be able to tell, is one object less than another object, or greater than another object, or equal to, right? That operation has to be defined. And because it is not defined for objects in general, we define this operation by implementing this IComparable interface. So if my square implements IComparable interface, then I know that I can actually compare them using this method. If I know that I can compare them using this method, then I should be able to use the sort. Because the method sort assumes that your objects have a compare to method. So then the method sort goes